Friction is a force that opposes motion or even the attempt to start motion. It acts parallel to the surfaces in contact and always in the opposite direction of motion. And depending on the situation, friction can either help you or make your life harder. Let's start with friction is one of those invisible forces that you never see, but you feel it everywhere. Every time you walk, drive, open a door, or even write with a pencil, friction is working behind the scenes. So let's break it down in a simple and clear way. Friction is a force that opposes motion or even the attempt to start motion. It acts parallel to the surfaces in contact and always in the opposite direction of motion. And depending on the situation, friction can either help you or make your life harder. Let's start with static friction. Static friction is the force that prevents a resting object from moving. If you try to push a heavy box and it doesn't move, that's static friction stopping it. There's a maximum limit called starting friction, the biggest force you need to apply before the object finally breaks free and begins to move. Once the object starts moving, kinetic friction takes over. Kinetic friction opposes the motion of a moving object, and it is always less than static friction. That's why it's harder to start moving a heavy cabinet than it is to keep it sliding once it's already moving. Kinetic friction comes in different forms. Sliding friction happens when two surfaces slide against each other, like a toboggan on snow. Rolling friction is what you experience with bicycle or car wheels, and it's much smaller than sliding friction. That's why the Egyptians used logs under giant stone blocks. Rolling friction made moving them possible. And fluid friction, also called drag, is what slows down boats in water and airplanes moving through air. Even surfaces that look smooth, like polished aluminum, are full of microscopic bumps. When these bumps rub against each other, they create friction. That's why friction is caused by electrical interactions between surfaces. Friction can be a problem when it slows down machines, wastes energy, or produces unwanted heat. To reduce friction, we smooth surfaces, add lubricants like oil or grease, use materials like Teflon, or install ball bearings. Ball bearings replace sliding friction with rolling friction, making movement up to 100 times easier. Even your body has its own friction-reducing system. In your joints, synovial fluid lubricates the cartilage so bones don't grind against each other. But friction isn't always bad. Sometimes we need more friction to stay safe. Tires gripping the road, shoes gripping the floor, screws holding wood together, or a doorknob turning in your hand all rely on friction. The Incas used very tight-fitting stones in their walls so friction would help keep the building stable during earthquakes. Friction also plays a role in motion. When an object moves at a constant velocity across a surface, the applied force must exactly equal the kinetic friction, making the net force zero. If the applied force becomes greater, the object accelerates. If it becomes smaller, the object slows down. Many factors impact friction: the type of surfaces in contact, the nature of the materials, the mass of the object, which affects the normal force, and whether the object is stationary or moving. Understanding these factors helps us design machines, vehicles, tools, and even sports equipment that work better and last longer. If you learned something new today, don't forget to like the video and subscribe. It helps us create more clear and easy physics lessons for you.